Okay, ladies and gentlemen, this video is on solving linear systems using substitution. We were reviewing this method in class today. Keep in mind, this is something that should have been taught in your IM1 class, but I want to review it with you because we're going to need it very soon as we get into more complex systems, okay? But here we go. Here was number 12 on our worksheet. And I want you to notice how both of them are equal to y, correct? And so whenever you have a situation where both of them are equal to y, well, logically, they must equal each other, correct? So couldn't I say negative 5x minus 7 equals 9x plus 21? Because they're both equal to y, and if we're solving a system, we're trying to figure out where they are the same, where they equal each other. Okay, so if you understand that step, now it's just a matter of solving the equation. So how about if we minus 9x both sides? Some of you prefer to keep the x's on the left side of your equation. So notice we end up with negative 14x minus 7 equal to 21. Because again, 9x minus 9x is 0, right? Continuing on, couldn't we go ahead and add 7 to both sides? And that leaves us negative 14x equal to 28. And then finally, let's just go ahead and divide by negative 14. And moving up here, we know x must equal negative 2. Because positive 28 divided by negative 14 is negative 2. Now we're not done, because remember, that's the x. We're now going to plug it in to one of the equations, and you can pick either one. I'm going to pick the first one since it has positive values in it. Excuse me. So we now know that y must be 9 times x, which we know is negative 2, plus 21. And again, all I did was plug it into the purple, now green equation. And just doing the math, that means negative 18 plus 21. And of course, that means y must be positive 3. So our final answer, our final solution, it's a good word to get familiar with, is x negative 2, y 3. And this is a point, guys. And let's make sure we understand what that means. So let's say instead of doing all this algebra, we graphed it. Could we find the solution? Well, here it is. Notice both equations, red and blue, they cross right there. That's the only point they have in common, right? And they cross and meet at negative 2, 3, which is exactly what we got in our answer, didn't we? So pause the video if you need to, guys. But again, remember, this is the mental picture you should have. We're trying to find where two lines cross each other. Okay? Now, let's just try one more with a little bit different format to it. So, look at number 5 from today's worksheet. Notice we still have y, in this case, y equal to 10x minus 30. But notice the second equation, the purple equation, is in standard form. So we can't just set them equal to each other. So instead, we're going to take the y and we're going to plug it in for the other y. So let's see what we end up with. In the purple equation, do we not have negative x there? Plus 2 times y. But remember, it's now going to be 2 times 10x minus 30. Because I, as shown in light blue there, just substituted the other y in for the purple y. And that, of course, will equal 16. And notice all I did was rewrite the purple equation, in other words, with the other light blue y inside the purple y. Okay, so now let's just clean up our mess. Hopefully you realize right here I better do distributive property. 2 times negative 30 is negative 60. And I still have my negative x. I still have my equal 16 at the end. Now notice I have some like terms. Both these x terms are on the same side. So I'm just going to combine them together, and 20 minus 1 is 19x. I still have my minus 60 equal to 16. Now let's go ahead and add 60 to both sides. Okay, so 19x now equals, looks like 76. And finally we're going to divide by 19, right? We're solving for x. 19 divided by 19 is 1x. And it just so happens, doesn't 76 divide by 19 equal exactly 4? So I now know my x is positive 4. Again, we're not done. We're now going to plug that back into our blue equation, since it's already solved for y. So we now know that y equals 10 times x, which we now know is 4, minus 30. And that's 40 minus 30, which so happens to be 10. So our solution this time is going to be x4 and y10, correct? And I'm just going to hope and pray I have the right graph pictured in the next screen. But the solution is 410, ladies and gentlemen. And let's see if it matches my graph. Hallelujah. Notice, guys, again, I have both graphed, the blue and the red lines. Let me clean that up, getting a little messy here. But notice how they cross at 410, don't they? At 410 right there. And that exactly matches our solution, doesn't it? So long story short, guys, I hope you study and understand this video and understand the big picture. We're looking to where the two lines cross each other. Anytime we're combining equations and graphs, we call them systems. And in this case, those two lines crossed at 410, correct? And that, of course, matches our solution right here, 410. So until next time, guys, bye.